finishing off the example from Friday, and we are trying to find the volume by evaluating triple integral of a sphere. Okay, so let's think about this. Infinitesimal variation, this thingy, rho varies a little bit, so it creates that little thickness. And phi varies tiny bit, right? So d phi is really here, and that thing is rho d phi, right? R theta concept, arc length, the radius, Greek R, rho, times d phi, A. Are you confused? And this thingy is same thing as that shadow moving here, so that's really R, and then little d theta. We good? So if you multiply this thingy, and this thingy, and the rho, you get this, 8. Then we can integrate this. So triple integral, we have rho square and sine phi and d rho, d phi, and d theta. Since it's a sphere of radius r, rho will vary from 0 to capital R. Okay? Now, in calculus, especially in multivariable calculus, we generally don't use lowercase r for radius because that's reserved for our vector function. So we use capital R a lot. And then phi varies from 0 to pi over 2. Remember, phi is the vertical phi angle that comes all the way down to negative z-axis, from positive to negative z-axis, and theta is all the way around. So that is our volume of a sphere with a radius r. Now your book does something called iterated integral, and they do all three at the same time, and you can, because rho is not a function of phi or theta, and these are all independent variables in the way they are written here, but I still don't like it that much. I mean, you can do it if you want to. Let's just do outside, inside out. So inside is rho cube, right? Therefore 1/3, and then sine phi and 0 to r and d phi d theta. Now here we are, when we did this first integral, we are only integrating with respect to rho, holding phi and theta constant. So it's kind of like partial derivative here, okay? Partial antiderivative. So this is 0 to 2 pi and 0 to pi over 2. Pi, did I put pi over 2? Oh my god, pi. Negative z-axis is pi. And none of you are paying attention. So if we plug in r here, then we get 1/3 r cubed. And then sine phi d theta, eh? Okay, r cubed over 3 is constant, so that can come outside. Now evaluating sine phi, so we get negative cosine phi a. Let's put it with the bracket. And then 0 to pi and d theta. Very good. Now evaluating this, do we just pick up 2 out of this? Yeah. 2 d theta. And of course, 2 is constant, so 2 r cubed over 3, and then we have theta. 0 to 2 pi, that also gives you 2 pi, so we have 4 pi over 3 r cubed. How about that? Good? Questions? Okay, now, suppose we have this. And we want to convert this into spherical coordinate, like u. Right? This is ugly. Okay, let me remind you, x is equal to rho sine phi cosine theta, right? And y is equal to rho sine phi sine theta and z is equal to rho cosine phi. And that's it, right? It's just a brute force substitution and simplification. Okay, it's not pretty. It's not designed to be pretty. So x squared, which is rho squared, sine squared phi cosine squared theta a, that's x, minus, and y squared, so rho squared sine squared phi, and then sine squared theta a, minus z squared, so we have rho squared cosine squared phi is equal to 1. You with me? Okay. Do you see that rho is a common factor? Okay. Rho squared, and then let's just take a look at this. Within here, between these two, sine squared is a common factor, isn't it? So we have sine squared phi, and then we're going to have cosine squared phi minus sine squared, phi theta. Uh-oh. And then, of course, my OneNote crashes, right? Oh, while I'm at it. No. I wanted to save this. Wow, Friday I lose internet. Today, OneNote crashes. Isn't that great? Is this class cursed? It always happens here, right? I mean, thank God it didn't happen in the middle of the test for me, God. Like I was giving BC tests, and what do I do if I lose it? And like, did it go out in entire palace release is what I was worried about. Okay, continue. Sine squared. Do they cancel? No, they don't cancel. But we know an identity about that one too, okay? So minus cosine squared phi is equal to 1, right? And I mean, we can stop, but if you want to make it pretty, sine squared phi, and this thing is cosine to theta. You remember forgetting that identity? And this is as pretty as it's going to get. Question? Okay, yeah, nobody in their right mind will convert this to spherical coordinate because it looks that ugly. Do you remember like converting lemniscate to polar coordinate? It was very ugly. Yeah, it's kind of like that. Okay, let's do this. Okay, now this one is a little bit more reasonable, but can you feel it? Do you see the sphere sticking out in y direction? What? Okay, before we do that, let's just like remind ourselves r is equal to, let's say, this one, right? Sine theta. What was this thingy in polar coordinate? Was it this? Was it this? Do you feel it? So if I multiply rho on both sides, this sure looks like y, doesn't it? So do you see that this is equivalent of sphere now? I'm gonna erase it and redraw 3D coordinate. Can I do this even? This is a lot more difficult than I thought. Let's say like, no. That's not the correct location. Do you see this thingy? And this is one sphere. Okay, those of you who cannot feel it, let's analyze it. Okay, I multiply both sides by rho because we used to multiply both sides by r for something like this. So we have rho square is equal to rho sine theta. Let me write sine phi first. Sine phi sine theta. Good. And then what is rho square? X squared plus y squared plus z squared, also known as super Pythagorean theorem, and the right hand side happens to be y now, isn't it? Bringing it over and completing the square. And then this, right? Obviously, too much algebra? You feel it? Okay, let's see if you can feel this. Rho is equal to pi over 3. Let's see if you feel this. Pi over 3, right? 60 degrees. Do you feel the cone? Pi over, oh, I screwed up the pictures. 60 degrees from the vertical. Let's just do it that. This is pi over 3. Do you feel that cone? Nay? Okay, let's analyze it. P is equal to pi over 3. Okay. We can take tangent or we can take cosine. Cosine is easier because cosine pi over 3 is a nice number. And we can take either one. This will do. Let's take cosine on both sides. Shall we? So we have cosine phi. And then we have 1/2, right? Multiply both sides by rho again. So we have rho cosine phi is equal to rho over 2. What is rho cosine phi? Is z. Can I square both sides now? But then what's rho square? Multiplying 4 over here. Rho square, of course, is this, right? Simplify. Now, since you have done sketched quadratic surfaces, you can feel this to be the cone now, right? But does this picture make sense to you? You come down pi over 360 degrees from the vertical, and then you have a degree of freedom. Let's talk about degree of freedom. Rho has no restriction, so it can go reach out to infinity. And then theta has total freedom, so it can go around and create this cone. This bottom side doesn't exist. But this thing does, I know, because we squared both sides. So we have extraneous root, the extraneous, but with the cone. You know what I'm saying? How about that?